Welcome to 1.4 solving absolute value equation. Now right here in the beginning, I have absolute value of x equals to a. What I'm going to focus on today is solving equations where it may have two solutions. So going on that, be mindful that absolute value equation can have two solutions, one solution, or no solution. But in this section, we're going to focus mainly on solving an equation where it has two solutions. So I repeat, sometimes it might have two solutions, no solution, or one solution. But here we're going to focus on two solutions, but be prepared if you may have an equation where it may have no solution or one solution. In this example, absolute value of x equals to a. When you have an equation where it has an absolute value of x, the goal is to always get absolute value of x by itself before we solve for the variable. So again, the first goal is to get the absolute value of x to be by itself. So we can't have anything in the front, we can't have anything in the back side, and then we can't have anything underneath, meaning when you have a fraction, we shouldn't have a denominator. We want to get the absolute value of x by itself when we're solving for absolute value equations. Now continuing, if you have absolute value of x equals to a, in this case we do have absolute value of x by itself, what you're going to do is you're going to write the inside twice. So my x is inside the absolute value lines. I wrote it twice. First, I said one of them equals to the original a, the positive a, and the second, I said it equal to the negative of it, so negative a. So, rewrite the inside twice, have one equal to positive a, and have one equals to negative a. Now, I use the variable a to symbolize that it could be a positive number here, and then a negative number here. So, for example, if this was 4, then that should be negative 4. If that was 7, then that should be negative 7, and so on. And you can see how we're going to apply the process to the first example. Example 1, the absolute value of 3x equals to 12. So looking at it, the absolute value is by itself, so I can rewrite it as two equations. So 3x here, and then 3x over here, equal positive 12, and then here equal to negative 12. So there's my two equations. All I did was rewrite the inside twice, have it equal to positive 12, have it equal to negative 12. That's all I did. Now I'm going to solve for x. This one, divide by 3, divide by 3. So x equal positive 12 divided by 3 will be positive 4. That's my solution. Over here, I'm going to do the same thing. Divide by 3, divide by 3. So x equal negative 12 divided by 3 will be negative 4. Alright, now I'm going to show you why these two solutions work. So first I'm going to test out 4. I'm going to plug 4 into x. So we have 3 times 4 with the absolute value of lines equal to 12. 3 times 4 is 12. Now, the absolute value makes the inside become positive. So the absolute value of positive 12 will become positive 12. So 12 equals 12, that's correct. Now I'm going to test out negative 4. So 3 times negative 4 with the absolute value lines equal to 12. 3 times negative 4, that becomes negative 12. Now, again, as I said before, the absolute value make the inside number become positive. So the absolute value of negative 12 becomes 12. Now, you see that the left side equals to the right side is true. So that's why you have two solutions. One is x equals 4, and the other one, x equals negative 4. Now we're going to do the same process to the second example, but we don't have to check because, again, I just show you why it works. Again, absolute value just makes the inside number positive, and we just check these two solutions and it worked. We're going to just solve the second example, and we don't have to check. Now, it's always best to check if it's correct. So first step is absolute value of x plus 5 by itself. Nothing in the front, nothing in the back, nothing underneath. So yeah, we're good. What we're going to do, I'm going to write the inside twice. X plus 5 equal to 2. And x plus 5 equals to negative 2. What I'm going to do next, solve for x on this one. So minus 5, x equals 2 minus 5, that's negative 3. So x equal negative 3. Over here, I'm going to do the same thing. Cancel out to 5, cancel out to 5. Negative 2 minus 5 will be negative 7. So our second solution is x equals negative 7. Now, if you want to check if it's correct, all you have to do is just plug in negative 7 into x and negative 3 into x. And when you do the absolute value, meaning you simplify and then do the absolute value, it should equal to 2. In example 3, we have the absolute value of x over 2 equal to 3. Checking, nothing in front, nothing in the back of the absolute value, nothing underneath. Absolute value is by itself, so I'm going to write it twice of the inside, x over 2. X over 2. 1 equals to positive 3. 1 equals to negative 3. Now, just a reminder, if you look at example 1, example 2, and example 3, they're all equal to a positive number. So again, all the example we're doing, it equals to a positive number. If you notice that if it equals to a negative number, then that means it may be one solution or no solution. So be very careful with that. Since I have on the left side x over 2 equals to 3, I want to get rid of the denominator. What I'm going to do, since it's a fraction, I'm going to multiply both sides by 2. And when I multiply to a fraction, it's going to be 2 divided by 2. I'm going to have left 1x equal 3 times 2, which is 6. So that's our first solution. I'm going to do the same process. I want to get rid of the denominator. I'm going to multiply left side and right side by 2. 2 divided by 2, I'm left with 1x equal negative 3 times 2, negative 6. So that are our two solutions. Now, example 4 is the absolute value of x minus 2 equal to 7. Nothing in front, nothing behind, nothing underneath. So, absolute value is by itself. I'm going to write the inside twice. X minus 2, x minus 2. One equals to positive 7. The other equals to negative 7. Alright, on the left, I'm going to cancel out the minus 2. So I'm going to add 2 here, add 2 here. So x equal 7 plus 2 is 9. So the first one is x equals 9. Now on the other one, same thing. Plus 2 here, plus 2 here. Negative 7 plus 2, that becomes negative 5. So our second solution is x equals negative 5. So here are our two solutions for example 4.